Hey guys, the question wants to know what is the major product of the reaction shown. This is very straightforward. The mechanism might not be that straightforward, but it's a alcohol reaction that you should definitely be familiar with. You should definitely know how to do reactions of alcohols with SOCL2, thionyl chloride. So basically, is your alcohol is going to act like a nucleophile and attack this excellent electrophile in the form of SOCL2, and so basically what will happen here is the oxygen is acting as the nucleophile. It'll attack the sulfur. Think of this SO as kind of like a carbonyl, right? So this is the electrophile here. It'll attack it, and you will get this intermediate, just like you would if you had attacked, let's say, like a ketone or something. And now here's my benzene, and it's a meta, so there's the CH3 like there, and there's a positive charge here. And this comes down, but this time now it kicks out a chlorine instead of the oxygen, and you get this. Okay, with a positive charge there. And then what happens is that chlorine negative, that chlorine nucleophile, or the leaving group, which is now going to act as a nucleophile, will come back and attack that carbon and kick out the oxygen, and you get this. But actually, as this bond leaves, it forms SO2 and kicks out the chlorine, and you basically get this guy plus Cl minus. And this Cl minus will then deprotonate that, and finally you'll end up with SO2 and HCl. And the formation, something that you guys should remember in organic chemistry, these small molecules like SO2, HCl, N2, CO2, any of those sort of two-atom compounds, they're typically very stable thermodynamically. They're very low energy compounds. Nature just really likes those. They're just very, very stable. And as a result, if you see a mechanism whereby you can kick out something like SO2 or N2 or any of those mechanisms, that's generally the driving force of the reaction. That's why the reaction happens, okay? So it's sometimes very easy to remember. Sometimes when I think about mechanism, I'm trying to remember how exactly does this mechanism work. I try to remember, oh yes, this is the mechanism whereby I kick out SO2, or I'm going to kick out CO2. Or, for example, when I think Wolff-Kishner, if you think about the Wolff-Kishner reduction, I think about the formation of N2 gas, nitrogen gas. That's what drives the Wolff-Kishner reaction. So, you know, I know it's very, very difficult to memorize and to remember mechanisms, but to make it easier for yourself, try to think of them in terms of what they accomplish, and sometimes it'll make it just a little bit easier to remember. So just looking at this, what will happen here is we'll get, you know, our final product, which will be just the chlorine in place of the alcohol, and the CH3 here, which will give us A as our final answer choice there. B basically puts the chlorine in the wrong place, so that's incorrect. Same with C. C has two chlorines, in fact, so that won't work. D, again, sort of very similar to C, and then E is just nonsense. So the correct answer here is definitely going to be A. Make sure you know your alcohol reactions for any standardized organic chemistry test. Okay, thanks guys. If you have any questions on the mechanism here or how any of this works, feel free to shoot me an email. I'd be happy to reply. Have a nice day and good luck with your studies.